In this video, we're going to use the Python visualizer to explore how function calls are managed in computer memory. We have written a function called convert_to_minutes, which takes in a number of hours and returns the equivalent number of minutes. For example, if we call convert_to_minutes with argument 2, then we expect to get back 120, because there are 120 minutes in 2 hours. Notice the indentation. All code belonging to a function must be indented, typically 4 spaces. Let's visualize what happens when we run this program. When we read the function definition, or rather when Python does, we see that a variable called convert_to_minutes is created. It contains the memory address of a function object. That function object contains all information about the function, including any code that needs to be executed, the parameter, and the docstring. We are now paused on line 10, which contains an assignment statement. Notice that variable minutes2 has not been created yet. That will happen after we finish executing the assignment statement. So first we have to evaluate the expression on the right-hand side of the equal symbol, and that expression is a function call. Once that function call has returned, it will give us back a value, and minutes2 will be created, and it will store the memory address of that returned value. In order to execute this function call, the argument is evaluated. That will create a box for value 2 to the right of the dotted line. In addition, a new region of memory will be created to keep track of what happens while convert_to_minutes is executing. Here is value 2, and here is variable num_hours, which stores the memory address of value 2. The area of computer memory to the right of the dotted line is called the heap, and contains all the values that are created during execution of a program. The area of memory to the left of the dotted line is called the call stack. It's called a stack because it's like a stack of plates. When a function is called, a stack frame is created on top of the stack. And when that function returns, its frame is removed from the top of the stack, and control passes back to the caller of that function. Each frame contains variables that are specific to that section of the program. The main frame contains variables that are created outside of any function, and frames for functions contain parameters and local variables. A local variable is any variable that is created inside of a function, such as variable result. Now that convert_to_minutes has been called, we're going to step forward in order to reach the body. Line 7 contains an assignment statement. We evaluate the right-hand side. We look up what num_hours is, and it's 2. 2 times 60 is 120, so we're going to see a value 120 get created, and we're going to see a variable result get created inside function convert_to_minutes. Result refers to 120. Num_hours refers to 2. We're about to execute a return statement. That's going to evaluate result, which is 120, and it's going to yield that memory address x3. Notice that we get to see what the return value is. As soon as we click forward one more time, we're going to exit function convert_to_minutes. Control is going to pass back to where we were in the program. That was right here. We're going to finish this call to convert_to_minutes with argument 2, and it's going to give us back the memory address of value 120. That should create a variable minutes2 down here in module main, and that variable minutes2 should store memory address x3. Indeed, that's what happens. The stack frame for the call to convert_to_minutes is gone from computer memory. That's what happens when a function exits. We're going to step through another call on convert_to_minutes. This time we're going to pass in argument 3, and we're going to save the result, store the result in minutes3 here. Let's watch that happen. We evaluate 3, which creates it in the heap. Num hours refers to that value now. It used to refer on the first call to value 2. Now it refers to value 3 because we've called it with a different argument. Now when I calculate num hours times 60, I look on top of the stack here and I see that I'm taking 3 times 60, that's 180. And so we're going to get a variable result referring to 180. We still have value 120 up here because outside of this function, minutes 2 still refers to it. Now we're going to return 180. That will yield memory address x5, which is going to be stored inside a new variable, minutes3, which will be created in this main module.